calculate, we learned how to calculate the slope of a line, which we labeled as M. We also learned how to calculate the intercept of a line, which we labeled as C. And then one of the equations of a line, we learned to write it as y equals mx plus c. So we learned various ways of calculating the m. And the m, we came out with a formula y2 minus y1 divided by x2 minus x1. Then we also learned that we could write equation also using the formula y minus y1 equals m into x minus x1. There were some three names that were given to these types of equation, and I quickly want to refresh your mind on them before we pick a practice problem today. So let's just remind ourselves of what we learned last week, the technical names we gave to the equations. And there were three of them. The first one we called the standard form equation, ax plus by equals c. The second one we called the slope-intercept form, which I just wrote, y equals mx plus c. And then the third one we called the point slope form, y minus y1 equals m into x minus x1. So today we want to learn how to use this one, slope intercept form, which can be changed. I proved it last week that you could change this one to become this, or you could change this one to become that. Now, the reason why the slope intercept form is popular is that when you draw a line, you can see all four variables showing: the y, the m, the x, and the c. So all the plottings you've done at the lower levels, secondary school, JHS, you were taught to plot graph on two axes. You have the y-axis, and then you have the x-axis. And they will give you a couple of points to plot. So after plotting the points, you were taught to join the points for it to become a straight line. And then you extend the straight line to come and cut the y-axis. So where the straight line is cutting the y-axis, you were taught to label that point as C, called the intercept on the y-axis. And then to know the steep, okay, like climbing a mountain, to know the steep of the line, you were asked to find the change in x and then the change in y, like a right angle triangle, the change in x and the change in y. So change in x means that locate your first point of x called x1, and then your final point of x called x2. And then your change in y means locate the first point of your y called y1. And then also locate the final point of your y called y2. So if you watch this one carefully, look at this area here. So this is what is going to give you the steep, or what we call the gradient. So in other words, if you are standing here and then you want to walk across this path in ascending order, so you keep climbing until you finally get to this point. What you have literally done is that you have walked this distance horizontally from here to here, and you have also walked vertically from the bottom to the top. So your walking is in two directions. You are walking horizontally, and then you are walking vertically. So when we need an equation to control your movement, all we write is as follows: that you are moving on the y-axis, and then you are on the path of a peak, change in x and change in y. So if you want to know the actual distance, change in x and change in y. So the actual change will be y2 minus y1, or the vertical, y2 minus y1 divided by x2 minus x1. And this is what we learned last week, that whenever you do this, you can use this letter to represent it. M. M is the slope. M is the gradient, which is written as y2 minus y1 divided by x2 minus x1. So in the equation, this is your y movement. You move in a steep way, change in x over change in y, called M. You are also moving on the x-axis. And then where did you start the movement from? If you are starting on the y, that is C, the intercept, plus C. So this is the slope intercept. That's where the name is coming from, slope intercept. M is the slope. C is the intercept. And then Y and X are like the road you are walking on. That's why I demonstrated it here. When you are walking this way, the X movement is horizontal and the Y movement is vertical. So today we want to plot a graph using the slope intercept form. And I needed to make you understand why you have this formula. So when we demonstrate it, you can get the full understanding. So let's pick a practice problem and learn how to do this. So I have a practice problem for you. Let's do it together. We want to plot these points and then find the necessary characteristics such as the slope, the intercept, and the equation of the line. Now I read the problem. The problem says, the following table gives values of advertising costs and sales of a particular commodity. Advertising costs and sales of a particular commodity in a certain city in Ghana. All the figures are in thousands of Ghana cedis. So X is representing the advertising cost. 20, 40, 60, 80, 100, 120. But once they are in thousands of Ghana cedis, you can say 20,000, 40,000, 60,000, 80,000, 100,000, 120,000. And then the sales is 100,000, 160,000, 220,000, 280,000, 340,000, 400,000. Now, we all know that sometimes in life, your sales can depend on the adverts you do. That is why a lot of companies do more adverts because their sales are depending on their adverts. Okay. So when one variable is depending on another variable in a form of a line, we use the straight line equation. So all the equation we have been writing for the slope for y equals mx plus c. It means that x and y are in a relationship. X and y are in relationship. And the relationship is in such a way that as x increases, it means y will also increase. As x increases, y will also increase. That is how the relationship is. So when you take this question, if advertising is x and then sales is y, it means that as the advertising increases, sales will also increase. And so when we are plotting, it means that if we have our axis like this, and this becomes our y, this becomes our x, we'll have a line like this because as x is increasing like this, okay, y is also going up. So you have a straight line which is moving from below to above. Because when x increases, it means that when here is 0 and here is 5, x has increased. Again, for y, if here is 0 and here is 10, it means y has increased. So as x increases, y also increases. Now, what are the demands of the question? These are the demands of the question. They are as follows. 1, it says we should plot a graph of the above data. So we are going to plot x versus y. X versus y. That's what we are going to plot. Then after the plotting, we are asked to calculate the slope, m. We are supposed to calculate the slope, m. Okay. And you know m, you know the formula we use when we are calculating m. We use y2 minus y1 over x2 minus x1. Then 3, we have to find the intercept of the graph. Intercept is represented by C. So we need to find C. And then IV, find the equation of the line, the slope intercept, equation of the line. So that is going to be y equals mx plus c. So by the time we get here, we have our c already. You can see that we have found our c. So we have c here, we'll just fix it here. And then the M also, we have found it here. So we just fix it here. And then this will give us the equation of the line. Now, once you have your equation, you can use your equation to predict. You can use it to predict future sales, or you can use it to forecast future sales. And that is what a lot of the companies do. So if you have your equation, they are asking you a question that calculate the sales value. Calculate the sales value when advertising cost is 70,000 Ghana cedis. When advertising cost is 70,000 Ghana cedis. And you know that the advertising cost is represented by X. So what it means is that put X equals 70 into the equation and then find the value you get for Y. So these are the 5 questions we are supposed to do. And let's start solving them. First of all, by plotting. So learn how to plot. In the event where you get a question like that, I'll give you graph sheets to plot it. So learn how to plot values. But let's do it together. So we are starting the plotting. Now, these are the values we have. X, they say all the values are in thousands of Ghana cedis, but we have removed the thousand. We are just using the initial numbers given to us. So let's start the plot. The first one is 20, X20, Y100. Then you continue. The second one is 40, 160. The third one is 60, 220. The fourth one is 80, 280. The fifth one is 100, 340. And then the last one is 120, 400. Question: how do you draw your axis? How are you able to draw your axis? This is what you do. When you are given your graph sheet to draw the axis, this is what you do. First of all, you draw the y-axis, and then second, you draw the x-axis. Then you look at the smallest value of x, which is 20, and then look for the highest value, which is 120. So if you look at the steps, 20, 40, 60, 80, 100, 120, it means you can use intervals of 20. So you start, this is your 0, 20, 40, 60, 80, 100, 120, and then you can stop somewhere. So this is your x-axis. And then when you come to your y, you have 100, 160, 220, 280, 340, 400. These ones are bigger than the first one. The first one, you could see that the differences are 20, 20, 20. So it was easier for us. But this one is not like that. The first difference here, 100, 160, 60. So you could see 60, 60, 60, 60. Okay. But the way the graph sheet is, you can't use the 60. So you have to use intervals of 100. So when you start from 0, your next point is 100. Then you move to 200. Then you move to 300. Then you move to 400. And then you can end at 500. Anytime you are plotting, and then you see that the difference between the numbers is more than 50. If the differences are more than 50, it means that the intervals here use 100. If the differences are more than 50, it means you need to use 100 in the intervals here. That was why when I checked the differences, 100 and 160 is more than 50. 160 and 220 is more than 50. 220 to 280 is more than 50. 280 to 340 is more than 50. And then 340 to 400 is also more than 50. So it means that we cannot use 50 here. We have to use the next 100. This is how to get your scale going before you start the plotting. So now that we have our scale, let's start the plotting now and see what we can have at the end of the day. So let's start the plotting. I'm back here. So we have labeled our axis. The x-axis is called advertising cost. So you write it there. So this is the x-axis. And then the y-axis is called sales. So that one also you write it there. And so this is your y-axis. Okay. Then the title of your graph is sales versus advertising cost. That's what we are doing. We are plotting the sales against the advertising cost. So first plot, when x is 20, y is 100. When x is 20, y is 100. And that's the first point you are seeing here. Second point, when x is 40, y is 160. Second point, when x is 40, y is 160. So this becomes your second point. Third point, when x is 60, y is 220. So when x is 60, y is 220. So this becomes your third point. Fourth point, when x is 80, y is 280. So when x is 80, y is 280. So you mark it out, and this becomes your fourth point. Then when x is 100, y is 340. When x is 100, so we hit, and then y is 340. So this becomes our fifth point. And then the final point, when x is 120, y is 400. So you have the last point. So I was using these lines for you to know that that is how you use your eye to gauge, to get the point. So when X is 20, you go and look for Y 100, and then you try and make them meet at a point. So whilst Y is coming this way, X is also coming this way, and then they will meet at this point, and then you circle it. Whilst X is also moving up 40, Y is also coming from the side, 160. So where they meet is your final point. When X is 60 moving up, Y will be coming from the other side, 220, to meet X. So where the two of them meet, that is the point. When X is 80 is moving up, Y 280 is coming from the side. Where they meet becomes your final point. When X is 100, it's moving up. Y 340 will be coming from the side. And where they meet will be your point. And then finally, when X 120 is moving up, and then Y 400 is coming from this side, where they meet will become your point. This is how you can plot these points. So after the plotting, let's see the dashboard you have. Because you are plotting a straight line, after the plotting, you should be able to join the points together. And that will form the equation of the line. It is showing us where the equation is starting from and then where it will finally end. So at the end of the day, these are the points we have plotted. You use your ruler to join one point to the other, like you are seeing here. So you join this point to this point, you join this point to that point, keep joining the points to one another with your straight line or ruler, straight edge. So when you join them, you will have a straight line like you are seeing. So at the end of the final point, you use your ruler to extend this point to come and hit the y-axis like this. So this will be your C. And then your change in X, you could pick 2 points. Change in X, and then this can be your change in Y. So you can decide that you are making this one your X1, and then you make this one your X2. Again, you can decide to make this one your Y1, and then you make this one your Y2. So when you are calculating the M, it becomes easier. You have your Y2, you have your Y1 divided by your X2 minus your X1. So that will help you to get the M. And then you have your C. And so in writing the equation, Y equals mx plus C, you are sorted. You have the M, you have the C. You just fix them. and then you have the results. But let's see how we can also use some form of calculations we learned last week to solve the others after the plotting. Assuming we don't want to use the graph to find the M and the C, and we want to go the calculation way, let's see how we can do it. So we are here, we've plotted. Now we want to go calculate the slope of the graph. So this is what you can do. The slope, this is the formula we learned last week. M equals y2 minus y1 over x2 minus x1. So in calculation, you can choose any of the points. You can choose any 2 points. Okay. You can choose any 2 points. Any 2 points. So example, I'm choosing these 2 points, 20 and 100. This one's 20 and 100. And then I'm also choosing 40 and 160. 40 and 160. If I choose these 2 points for my slope, then this is what I'm saying. I'm saying that this first x is my x1. This second x is my x2. This first y is my y1. This second y is my y2. So I just fix them in the formula. So m equals y2 minus y1 over x2 minus x1 will be written as y2 is 160 minus y1 is 100 divided by x2 is 40 minus x1 is 20. When you solve this, you have 60 divided by 20, and that will give you 3. It means that m will be 3, and that's what you are having here. 160 minus 100 divided by 40 minus 20, and so the m will give you 3. Somebody else will say, okay, I won't use the first 2 points. I also want to use some different points. So somebody will say, I'm using 60 to 20, and then I'm using 80 to 80. In the same way, this one will be your y2, this one will be your y1, this one will be your x2, this one will be your x1. So same formula. Use same formula to do the calculation. So it means that when you use 60 and 220, or you use 80 and 280, the same thing will happen. So M will be written as 280 minus 220 divided by 80 minus 60. If you work this out, you get the same 3, same answer. Or another person too will say, I also want to use 100 and 340 and then 120 and 400. So that this time my y2 is 400, my y1 is 340, my x2 is 120, my x1 is 100. So same thing when you fix it. Y2 400, Y1 340, X2 120, X1 100, and you still get 3. So no matter the 2 points you pick from the graph, you are going to get the same slope along. It will not change. The M is constant, the C is constant. So that will not change. Yes, Stephen, unmute yourself and ask your question.
Please, good morning and good morning, class.
Good morning.
Sir, please, with the slope, is it always advisable to choose only two numbers, or you can decide to choose from the first number to the last number?
The question is you choose 2 points, not two numbers. 2 points. Two
Oh,
points, not two numbers.
okay, sir.
So a point is X and Y. So this is a point. This is a point. So you choose 2 points. This
Okay.
point that you only choose 2 points because we have Y2 minus Y1. The two you are seeing here is second point. And the one you are seeing here means first point. That's what it means. So you don't choose two numbers, you choose 2 points. Is
Oh,
it,
okay.
is it clear?
Yes, sir.
All right, so
Thank.
let's continue. Yes, let's continue with the rest. So now we have the slope. The slope M, we had 3. And so it's time for us to look for the intercept. The intercept is represented by C. Let's see how we do that. So intercept of the equation is C. Where can we get a C? We can get it from the slope intercept relationship. Y equals mx plus C. So all we do here is we make C the subject. So the change of subject we learned, we'll apply them here. So we say making C the subject. We have Y equals mx plus C. So remember what I taught you, swap. C will have to be on the left-hand side. So we swap. We swap the whole of the right-hand side. So we have mx plus C is equal to Y. So swapping means bring everything here to the left and then bring everything here to the right. That's what I've done because I want the C to be on the left. That's what I want. So this will have to move because it's C I'm looking for. So therefore, C will be equal to Y minus mx like this. This is the formula we can use to find the C. C equals Y minus mx. At this point, I don't have a problem with M because we have found M and we had 3. Okay. How do we get Y? How do we get X? To fix them to get C. So Y and X means go to the table we had. Go to the table we had. And you see that the table is made up of the pair of X and y. And the values we saw 20, 40, 60, 80, 100, and then 120 for the x values. And the y values, we saw this for the y values. We saw 400 for this last one. We saw 340 for the 100. We saw 280 for the 80. We saw 220 for the 60. We saw 160. So 400, 340, 280, 220, 160, and then 100. So for the C, you can use any of this point to represent X and Y. After all, that's what we are seeing here. These are the X values. These are the Y values. So you can choose any X and Y and fix it here. So assuming I'm choosing 20 and 100. If I'm choosing 20 and 100, then I'll say choose X equals 20, Y equals 100, and fix in the equation. So this is what is going to happen. So I have C is equal to Y is 100 minus M is 3, X is 20. So C will become 100 minus 60. And finally, C will give me 40 as an answer. What if somebody decides to choose the last point, 120 and 400? Let's see what will happen. The same equation. C is equal to Y minus MX. So let's fix it. C is equal to, this time Y is 400. So we write there 400 minus M, we have found already. M is 3. So we fix the 3 there. And then X is 120. Let's keep working. We have 400 minus 3 times 120 will give you 360. Therefore, C is equal to 40. So you see that we have the same answer. Okay. The same answer. C is equal to 40. So no matter the point you choose, you still come and get the intercept as C is equal to 40. And that is how to find the intercept. So at the end of the day, we have a C to be 40. So this is done. This is also done. We are at question number 4. Find the equation of the line. Find the equation of the line. Equation of the line, I told you, is written as Y equals MX plus C. y equals mx plus c. Let's see whether we have everything to finish this equation. We have found m. We have found c. Y is representing y-axis. X is representing x-axis. Therefore, we can write our final equation as y is equal to m is 3, x plus c is 40. And this is our final equation. 3x plus 40 is the equation on the line. Now, in mathematical terms, let me explain to you what we have done and the reason why you have been hearing this thing in business called business model. I'm sure you've been hearing about business model. A company is using a particular business model, okay, to work. Now, what we can say this morning is that our business model for this data, our business model for this data is what you are seeing here. Y is equal to 3x plus 40. What does it mean? It means that when you know x and you don't know y, you can use this equation to find y. And I want us to prove it. So this is the model. The equation of the line has now become our business model because it's going to generate all the y values for me. In other words, we have compressed, let me use that word, we have compressed the data. We have compressed the data in a form of a model equation. So this is our model equation. We don't need to write all this again because when we look at our equation, it can generate everything we want for us. And let's prove it. Let's check the reason why I'm saying that the equation of the line has become our business model. That anytime you see this data is controlled by this equation. Y equals 3x plus 40. Let's check something. Let's assume we don't know this. We don't know this. We don't know that. We don't know this. We don't know this. We don't know this. And we only know this, the top ones. We only know this. Let's see how we can find the y. So this is our equation. Y equals 3x plus 40. Now this is the point. When x is 20, what will be y? We are going to fix it here. Let's fix x equals 20 here. So we have y equals 3 times 20 plus 40. And this will give us 60 plus 40. And then the answer is y is equal to 100. That's what you are seeing here. So you see, we have used the model to find the value of y, assuming we didn't know it. What about the second one, when x equals 40? Let's check that one too. When x equals 40, you have y equals 3 times 40 plus 40. So we have y equals 120 plus 40. So finally, y gives us 160. That's what you are finding here. y is 160. Let's do the last one. Assuming x is 120 and we don't know y, we use our model. Y is equal to 3 times 120 plus 40. So we have y equals 3 times 120 will give you 360 plus 40. And then this finally gives you y equals 400. And that's the 400 you are seeing. Okay, so in essence, we use the equation of a line to develop business models like you are seeing here. So now we are not afraid. If somebody asks you, okay, so this is your model. What if the x, we increase the x to 400? What will be y? When we increase the x to 400, what will be y? You just use your model. Y equals 3x plus 40. So you have y equals 3 times x is 400 now, plus 40. So y will give you 1,200 plus 40. And finally, you have y equals 1,240. That's your answer. So it means that even though in the table we were not given this one, we can use our model to find it and add it to our table. That is how it works. But in our question, we were asked that assuming you are going to spend 70,000 on advertising cost, what will be the sales of Y? In other words, assuming you are not going to spend 60, 80, 100, 120, but you are going to spend 70. So the 70 is here. What will be the value for this one? Y. This is what they want you to find. Assuming X, advertising cost is X. Assuming X is equal to 70, what will be Y? Now the 70,000 you are seeing here, I have removed the last 3 zeros because when you look at this question, it says that all figures are in thousands of Ghana cedis. So this that you are seeing here is actually 20,000, but we have removed the 3 zeros at the back. So 70,000 to, you have to remove the 3 zeros at the back. So assuming X is 70, what is Y? We just use our model. Our model is Y equals 3X plus 40. It means wherever we see X, we put 70 there. We have Y equals 3 times 70 plus 40. So this becomes Y equals 210 plus 40. And finally, we have Y is equal to 250, which makes a lot of sense that we have 250. And that is the end of this question. And I'm sure when you see something like this in exam, it may take you about 30 minutes to solve it. So you have to watch this video again. Any question? Let me now open the floor for your questions. Any question so far from the question we have solved? Any question?
Hello, sir.
Yes, go ahead.
Good morning.
Good morning.
Yeah. So What I wanted to ask is what you just did. That is the 70 and the 250 bar. Is there a scenario where you are not giving 70, you are not giving the 250, and then you have to find maybe a missing point?
No, they always give you one. They
They
can't.
always give you, okay. So and also when you're asked to calculate the slope of the graph, meaning when you get the slope wrong, the rest of the calculations you do will also be wrong.
Exactly, because you can see from what we are doing
Yes.
that we are getting the answers here
Okay.
because the slope is correct. If the
Yes.
slope were to be wrong, we wouldn't get the answers.
Okay.
That is why you have to check your slope calculation very well.
Okay.
And then the intercept, when you even get the intercept wrong, you will still not get the answers. Because
Yes.
assuming the intercept, we made a mistake. We didn't write 40
Yeah.
and we wrote 30 over there. We will not be able to get the Y answers you are seeing here.
Okay.
That was why initially I was trying to prove them here one by one for you.
Yes.
And if you pick this one, for instance, and then X is 20, we are using the X is 20. We
Yes.
don't know Y, we want Y. So when
Okay.
we fix the 20 and assuming we had this intercept wrong, but we wrote 30 instead of 40, we wrote 30. See that when we add this one up, instead of getting 100, we'll come and get 90.
Yes.
But when you go here, it is not 90, it is what?
Yeah.
100.
Okay.
So always, it's not only the slope, always both the slope and the intercept where it is starting. This is the
Yeah.
fourth. They are all important. If you live here and you come somewhere here, you get it wrong. If you come below, you get it wrong. It has to be exactly on that point. That is why we've spent a lot of time learning how to calculate the slope
Yes.
and then the intercept. You make sure you are taking 2 points, two of it, any 2 points.
Yes.
Like Steven was asking me, not two numbers. You can take 2 points. You can take either this one
Mm.
and this one. It shouldn't even be like it should be close.
Okay.
You can take the first point and the last point. It will give you the same answer.
Oh.
You can take the second point and then the last but one. It will give you the same answer. So you always have to be careful about your slope. And if you don't calculate your slope well, you may have the answer wrong. Very,
Oh.
very important.
So when you're asked to calculate the intercept, and then let's say the one we had first is 40. So when you get a 40 and you want to be sure that your answer is correct, you have to pick 1 point and fix it into the formula to be sure if you still get the same answer, for you to be 100% sure that your answer is right.
Yes, you can do that, but once your slope is correct, the intercept will be correct
Okay.
because the intercept is depending on the slope. Look at the slope.
Yeah.
As for this y and x there, you are finding it from the table.
Okay.
So there's no problem. But if your m is wrong, it's going to affect the c. Then the c2 will be wrong. That is why it is always important to make sure you are calculating the m very well. There shouldn't be a problem with the m. You should get the m correct. Once the
Okay.
m is correct, the c will also be correct. Is it okay?
Yes, sir. It's okay, sir. Thank you.
Right. Any other question? Any other question about the slope? If you have a question, let's clear your mind and then we can go to another thing. All right. So let's use the rest of the 1 hour to continue solving some questions in equations now that you know how an equation is. So I'll be giving you simple questions like this to be solving. Let's try and do some of them. And then I'll let you try one and show me the answer. So let me do the simple one for you. Now 3x plus 2 equals 10. So the question is, find x. Find x. So like terms together, this 2 is not part of x, it's part of a number, so it has to go to the other side. And so you have 3x is equal to 10 minus 2. 3x is equal to 8. We want x to stand alone, so we divide every side by 3. This 3 cancels this 3. Therefore, x is equal to 8 over 3. So you can leave your answer like this. Or you can use a calculator to change it into decimal. So that is the first equation. Now the second equation I want us to solve. This time you have, yes, go ahead.
I wanted to ask, like, let's say if the question says leave your answer in the decimal, then you must not leave it this way.
Yes. So when there's a specific instruction,
Yeah.
you use decimal, then you have to change it to decimal. But if it is silent, if it just says solve for x, and it didn't tell you to leave your answer in fraction or decimal, you leave your answer in a fraction. Are you clear with that?
Yes, please.
Okay. So let's solve the second one. Well, let me allow you to solve the second one. Solve the second one. I'm just giving you 1 minute. Solve the second one and then let's do it together. So 2x minus 5 equals 5x minus 2. Find x. So solve it at your end. I'm just giving you 60 seconds to get me the answer. All right, so who has the answer? Okay, yes, Steven, what did you get?
Sir, please, x negative 1.
X negative 1. Okay, let's do it together. Steven had x is equal to negative 1. Okay, let's solve it. So like terms together, 2x minus 5 equals 5x minus 2.
Yeah, I got
Right?
the same thing.
Okay, good. So we have 2x minus 5x equals minus 2. Negative 5 is positive, so it becomes positive 5. We have negative 3x is equal to positive 3. We want x to stand alone, so we divide every side by negative 3. Negative 3. Negative 3 cancels negative 3. So x 3 cancels itself 1. Goes here 1. So you have 1 divided by negative 1, which is the same as negative 1. So that's a correct answer. -1. Good. Let's now move higher. So now we have this one, find x. Let's do it together again. We expand. 5 times 2x, we have 10x plus 5 times 3, we have 15. Is equal to 3 minus 2 times 3x, you have 6x. Then watch this one, -2 times -5. That will be +10. We have, let's group them now. So 10x, like terms together, this -6x will come. So it becomes +6x. Is equal to, we have this 3 here already. We have this +10 here also. And then this 15 will be moving. It's positive. When it moves, it becomes negative. We have 16x to be -2. This is 13 minus 15. So it gives you -2. We want x to stand alone, so we divide every side by 16 by 16. 16 will cancel 16. X equals 2 will cancel itself 1. 2 will go here, 8. So we have our answer to be x equals -1/8. Any question about this? X equals -1/8. So sometimes your answers will be negative, other times they will be positive. Whether they are negative or positive, they are all correct. All right, so let's move higher. Now we have the fractions coming in. That is where sometimes, if you're not careful, you get confused. So anytime fraction comes in, remember LCM will have to show up somewhere. Okay. So let's do that together. We can find LCM here like this. LCM between 3 and 4, we can use 12. 3 will come here, 4. 4 times 1, you have 4. You bring your positive sign. 4 will also go into 12 3 times. Then you multiply the 3 by the whole of this top. So this is how you write it. 3 multiplied by x minus 3. Like this. Is equal to the left-hand side, 2x plus 1 divided by 2. So we repeat, 2x plus 1 divided by 2 is equal to, we expand the top, 4 plus 3 times x, you have 3x. 3 times -3, you have -9 divided by 4. So we try and simplify. We have 2x plus 1 divided by 2 is equal to, now look at it, 4 minus 9. You get -5. So this will be 3x minus 5 over 12. Now at this stage, because we have a numerator divided by a denominator is equal to a numerator divided by a denominator, we have to use the principle of cross multiply. So we are going to cross multiply. So it means that cross multiply means this 12 is going to multiply this, and this 2 is also going to multiply this. So we can rewrite them as follows. 2 multiplied by 3x minus 5 is equal to 12 multiplied by 2x plus 1. And then we can expand. 2 times 3x, we have 6x minus 2 times 5, we have 10 equals 12 times 2x, we have 24x plus 12 times 1, have 12. So like terms together, this 24x will join the 6x. So you have 6x minus 24x is equal to 12. This negative 10 is crossing over. So it becomes positive 10. So let's continue. 6x minus 24x will give us negative 18x is equal to 12 plus 10 will give us 22. We divide every side by negative 18. Negative 18. And we do the cancellation. Negative 18 will cancel itself. So we'll be left with x. Now 2 goes here, 11. 2 goes here, 9. So we have 11 divided by negative 9. And whenever you are doing fractions, you don't keep the negative down. You have to bring it up. So therefore, our final answer will become negative 11 divided by 9. Our final answer. So this has been a long solution. Look at where we started from. Sometimes that is how the solution is going. It's going to be longer until you get the final thing. Any question about this one also? Yes, Agbe.
Sir, please, can you also do it like after finding the LCM for both sides, then you multiply it by, if after finding the LCM, which is 12, then you multiply it by both sides?
Yes, you can also do it that way.
Yeah. Okay.
Any other question? Okay, very good. That was a good question. So let's do the last one and then move to another thing for today. So the last one, they can give the expression in decimal. So that is why you need to be a bit careful so you don't miss your steps. So let's start. Let's multiply through 1.5 times x, you have 1.5x plus 1.5 times 2, you have 3 equal to 2.8. Okay, let me not confuse you here. Let me write it the way it will appear on your calculator. 1.5 times 2 will give you 3.0 equal to 2.8 plus x. Like terms together. So 1.5x minus x equals 2.8 minus 3.0. So you have 0.5x is equal to negative 0.2. Now we want x to stand alone, so we divide every side by 0.5, 0.5, and then we do some cancellation. So 0.5 will cancel itself. Then x can stand alone like this. Then for this one, in decimal, when you shift the point up to the right, you do same below. So we shift this one to the back of the 2. We do the same movement to the back of the 5. So it becomes negative 2 divided by 5. Our final answer. Any question about this? That is
A question, sir. A
yes.
question.
Go ahead.
So, sir, with this decimal equation, can
Mhm.
you, when you are given a decimal equation like this, can you first of all change it into fraction? Then after solving, then probably you change your answer to decimal.
Yes, that is also possible. But that's going to
But
take that's going to
the
take
reason why
a
I'm
long
saying,
time. Mhm.
yes, the reason why I'm saying this is that assuming you don't have a calculator or something, with the fraction you can easily do some calculation and arrive at the answer. So
But
in
this but
case,
this one but this one we didn't use a calculator. Or you thought we used a calculator. We didn't use a calculator.
oh, okay,
Yes, we didn't use a calculator. Look at it. 1.5. I hope you know that there is one here we don't write.
yes,
Uh-huh.
yes,
So all we did was that 1.5 minus 1. What will you get? 1.5 minus 1 is 0.5, isn't it?
oh, okay, okay,
So we didn't use a calculator.
okay.
Yes,
But
but
then, like I was
as
saying, you
we
can change it to fraction.
yes.
You can
So
change it to fraction, you solve it, and bring the answer to decimal.
yes, so when you change it to fraction, it's possible, but I'm saying it's going to be a long route. So for instance, this one, when you are changing this one to fraction, to become 15 over 10x plus 3 is equal to 28 over 10 plus x. So then you are going to find LCM. You can do it, but I'm saying that it's going to take a longer route, but you end up
It
getting the
is,
answer. Yes. So if
oh,
that is what
okay,
you're comfortable with, why not? You can use that to get your
okay,
answer. Yes.
okay. That's fine. Thank you,
Yeah.
sir.
Okay. That's a good question. Any other question? All right. So let's try and do the final thing for the day before 9 a.m. We have about 41 minutes. Let's use it to finish what we have to finish today. And the final topic we are doing today is called the simultaneous equations. And I'm sure most of you have come across it um, time and time again from the lower levels. The simultaneous equation simply means that you are finding unknown values by doing two things at the same time. What are the two things? It means you are solving two equations at the same time. All the ones we have done previously and you have asked your question, they were all one equation, one equation. But this time we want to solve two equations at the same time. And that is what is known as simultaneous equation. So you see that in life, there are scenarios whereby you'll be forced to solve two equations at the same time. Now, if you look at the economics that you may be taught I don't know, maybe they have not started with you, but they will teach you economics, and then they will try and explain to you something we called the demand curve, and then the supply curve. And this is what is controlling prices. Any item that is expensive is being controlled by these two equations. So we have a demand equation, and then we have a supply equation. So normally what happens in real life is that we all want things. So if you take an area of y and x, this is what happens. Whilst demand is going up, so this is the demand curve. Whilst demand is going up, okay, supply is also coming down. So this is the supply curve. So demand is going up, supply is coming down. They have to meet at a point, this point. The point they meet is what we call the market equilibrium. That is where everybody agrees that, okay, we'll pay for this price. So example, Trotro people are saying that from Accra to Kaswa, they are charging 20 cedis. That 20 cedis is the market equilibrium price, meaning that demand and supply have solved an equation. And the answer they had was, let's charge 20 cedis from Accra to Kaswa. So the drivers are okay. The passengers are also okay. Why? Because the drivers who are the supply, who are handling the supply curve, and then the passengers who are handling the demand curve, all of them have met at a point called the market equilibrium. And what is it? The price of the fare that they have all agreed. Driver says, I'll charge 20 cedis. Passenger says, I'll pay. So take me to my destination. That means that two equations have been solved at the same time, and we have a result. On the other hand, if another car comes and it says that, as for me, I'm going to charge 50 cedis from Accra to Kaswa, it means that equation has not been solved. The passengers will complain and they will resist because the driver has changed from the market equilibrium. Equation has not been solved. Or if a car comes and it says that, oh, as for me, I'll charge 1 cedi to Kaswa, I'm sure you'll be afraid. You'll be asking yourself questions like, how can the same car, Toyota Hiace, whilst it's supposed to charge 20 cedis, it is saying it is charging 1 cedi? I mean, what is happening? Why? Because he has also left the market equilibrium. So anytime you have two equations, when they meet, their meeting point is called the point of intersection, meaning that at this point, all the equations are passing there. All the equations are passing there. And so if this is your equation 1 and this is your equation 2, and they all meet at this point, it means that the x you are seeing here is the same x you are seeing here. The y you are seeing here is the same y you are seeing here. And so let's learn how to solve two equations to get their point of intersection, which will satisfy both equation 1 and equation 2. And like I've explained with the economic theory, let's create our demand equation, let's create our supply equation, and let's see their market equilibrium point, whether it can satisfy both the demand and then the supply. This is an example. We want to solve these two equations. These two equations both have x component and y component. So the thing we are doing is that what will be the value of x and what will be the value of y in such a way that when you get them and you fix x here and you fix y here, the answer should give you -4. In the same way, when you fix the same x here and you fix the same y here, the final answer should give you -21. And that's what we want to do. So the strategy is as follows. First of all, you label this equation as your equation 1. Fx plus 2y is equal to -4. You label it as your equation 1. Then you write the second equation, 6x minus 3y is equal to -21. You label this one as your equation 2. After that, rule a line below equation 2. Then the next thing we want to do is we want to change equation 1 to become equation 3. And then we want to change equation 2 to become equation 4. After that, we rule a line again. I repeat. After labeling equation 1 and equation 2, rule your line this way. And then the next thing to do is we are changing equation 1 to become equation 3. And then we are changing equation 2 to become equation 4. After that, rule your line again. The next thing is, how do we change equation 1? How do we change equation 1 to become equation 3? How do we change equation 1 to become equation 3? This is what you do. You make sure that all the x's are starting. What I mean is that if you see x here, when you look down, you have to see x. And then here too, if you see y here, you have to see y here before you start the movement. Make sure that all the variables are aligning. All the variables are on the same line. Okay. So question, how do you change equation 1 for it to become equation 3? So you stand on equation 1 like this. You stand on equation 1 like this. And then you look down. When you look down of equation 1, okay, you are seeing the number 6 here. I repeat, when you want to change equation 1 to equation 3, stand on equation 1. So we are standing on 5x. When you look down, you are seeing 6 here. Now this 6 you are seeing, multiply the whole of the equation 1 by 6. This 6 you are seeing here, you pick equation 1 and then you multiply the whole of equation 1 by the 6 you are seeing here. So this is the results you get. 6 times 5x will give you 30x plus 6 times 2y, you will have 12y equals 6 times negative 4. That will give you negative 24. And this becomes your equation 3. I repeat, in changing equation 1 to equation 3, stand on equation 1 and look down. What number do you see? 6. Pick the 6 and multiply it by the whole of equation 1. You have 30x plus 12y equals negative 24. And that becomes your equation 3. After that, you change direction. It is now the time for you to change equation 2 to become equation 4. So now we are changing equation 2 to become equation 4. So in that case, we come and stand on equation 2. That's what we are changing. So we stand on equation 2. When you look up, what number do you see? 5. So it means that you multiply the whole of equation 2 by the number 5 that you are seeing. So you pick equation 2. So you have 5 multiplied by 6x. That will give you 30x minus 5 multiplied by 3y. You have 15y equals 5 multiplied by negative 21. You have negative 105. And this becomes your equation 4. I repeat, to change equation 2 to equation 4, stand on equation 2, look up. What number are you seeing? 5. So you multiply the whole of equation 2 by the 5 you are seeing. So 6x times 5, 30x, minus 3y times 5, 15y, equals negative 21 times 5, negative 105. This becomes your equation 4. So the next thing to do is that now that you have equation 3 and 4, just subtract equation 4 from 3 by writing 3 minus 4. It means you are taking the one below from the one above. So we go this way. 30x minus 30x, you have 0. Now look at this one. 12y minus 15y. 12y minus 15y. The two minuses will change to positive. So you have 12 plus 15. That'll give you 27. 27y is equal to. Now look at this one also. Negative 24, negative 105. Negative 24, negative 105. Remember, this will also, two negatives will move to positive this way. Then at the end of the day, if you do this on your calculator, negative 24 plus 105, you get 81. So this will give you 81. So now see, the equation has reduced. Now I have 27y equals 81. Let's solve it now and finish up. And then I can open the floor for your questions. So 0 plus 27y equals 81. So you have 27y equals 81. We divide every side by 27. Then we do our cancellation. So 27 will cancel 27. We have y equals, now let's use 9. 9 will go into 81, 9. 9 will go into 27, 3. 3 will cancel itself, 1. 3 will go into 9, 3. So finally, y is equal to 3. After getting y is equal to 3, it means we can pick any of the equations to find the x. We can either pick 5x plus 2y equals minus 4, or 6x minus 3y equals negative 21. All of them will give us the correct answer for x. So let's use the first one as follows. 5x plus 2y is equal to negative 4. So we are looking for x, we have y. So this becomes 5x plus 2 times 3 is equal to negative 4. We have 5x plus 3 times 2 is 6 is equal to negative 4. 5x will give us negative 4. This one comes here, negative 6. 5x will give us negative 10. Divide every side by 5. Then finally, this cancels that. So we have x is equal to 5 here 1, 5 here 2. So x is also negative 2. So it means that our solution is that x should be negative 2, y should be 3. Let's check whether it is true that x should be negative 2 and then y should be 3. The same question I asked here, that what should be x, what should be y. Now we have the answers. The answers says that x should be negative 2 and then y should be 3. Let's check whether these answers are correct when we substitute them in this equation you are seeing here. Let's do this one first. So 5x, x negative 2. So negative 2 plus 2y, y is 3. Let's work it out and see. 5 times negative 2 is negative 10 plus 2 times 3 is 6. Negative 10 plus 6 is negative 4. So it is correct for this one. Let's check the second equation, whether that one also we can get it right. The second equation, 6x means 6, x is negative 2, minus 3y means 3 times 3 So 6 multiplied by -2, we have -12. -3 times 3, we have -9. -12, -9 is -21. So this is also correct. Therefore, our answers to this simultaneous equation are that x is -2 and then y is +3. Any question about this?
Yes, sir. Question, sir.
Yeah, go ahead.
Okay, so in the two equations, we multiply 5 and 6 to eliminate x. So does it mean that we can do same with y by multiplying equation 1 and 2 with the value with the coefficient of y to get the same answer? For instance, if instead of five, multiplying 5 with equation 6, with 6, let me come again. Instead of multiplying 5 with equation 2, then also multiplying 6 with equation 1, can we also multiply 2, the coefficient of y2 by equation 2 and 3 by equation 1 in that order?
Yeah,
So
so
that when we do that, we eliminate y, then we first of all find x.
what I said was that make sure the variables are matching before you start. So assuming this one was written this way, 5x plus 2y equals -4. And then the second one was -3y plus 6x equals -21. Because they are not matching, you cannot use the formula, I thought. The top is x, the down is y, the top is y, the down is x, they are not matching. So you can rearrange it, whether x or y, anything you want to lead. So if you want y to lead, then you rewrite it as 2y plus 5x is equal to -4. And then the second one, -3y plus 6x equals -21. So that in that case, they can now match. You have y to y, and then you have x to x. And then you can use it. But normally the equations, simultaneous equations, you normally target the ones that are given first. If they write y first, then make sure all the y's are starting. If they write the x first, make sure all the x are starting. That is all. So this one too can work, but you have to follow the order. And this is the order you were given, that x should be the first variable, y should be the second variable, x should be the first variable, y should be the second variable. On the other hand, if they change it and they say y should rather come here and x should go here, you just keep working with the first variable and not the second variable. Is it clear?
Yes, sir. So
Okay.
in that case, meaning we cannot.
No, it's not like you cannot. You can make mistakes in a rearrangement. You can make mistakes in a rearrangement, especially when there's a minus and you don't bring it. But if the equation is written this way for you, if the equation is written this way for you, that's what you do. If y is starting, so you start with a y. Are you seeing it? If it's written this way for you,
Yes, sir.
then you start with the y. But if it has been written this way for you, starting with the x, then you need to start with the x. So it depends on how it is written. And then you start with. But if you also want always y to be leading, then you have to be careful when you are writing them, else you make a mistake in the arrangement. Okay. Yes, is there any
Okay,
other
sure.
question? Yeah. All right. So now that you know how to solve it, or some of you too know how to solve it in your SHS way, you can go ahead. They are all correct. This was a new technique I'm teaching you. But these are the kinds of questions you'll be asked, not the ones that I showed you here. These are the questions you'll be asked. Story problems. Story problems. So let me solve one of them with you, and then you can use the weekend to look at the rest. I have more of them. This is a second one. This is a third one. This is a fourth one. Okay. But let me just do one with you. And I'm sure once we are done, you can do the rest. Let's see how we can solve real life problems using simultaneous equation. So this is a real life problem. At the Accra shopping mall, the cost of an iPhone is X cedis. It means that they have hidden the cost. And the cost of an Android phone is also Y cedis. Now, if James bought 3 iPhones and 4 Android phones at the cost of 6,350, and then Peter also bought 4 iPhones and 3 Android phones at the cost of 6,950 Ghana cedis. Question: find the cost of the iPhone. Find the cost of the Android phone. This is a simultaneous equation. The cost of iPhone is X cedis. The cost of Android phone is Y. Let's write the equations for James and Peter. This is what happened. James bought this. James bought 3 iPhones and then 4 Android phones at a cost of 6,350. So when we are writing this one in equation form, it is 3x plus 4y is equal to 6,350. This is our equation 1. Let's look at Peter. Peter, on the other hand, bought 4 iPhones and 3 Android phones at the cost of 6,950 cedis. You write this in equation form, that is 4x plus 3y is equal to 6,950. We have our equation 2. So we can perform our simultaneous equation. So let's perform our simultaneous equation that we have learned today. We have 3x plus 4y is equal to 6,350, equation 1. Equation 2, we have 4x plus 3y is equal to 6,950. equation 2. Our strategy we have learned today means that draw a line. We are now changing equation 1 to become equation 3. And then we are changing equation 2 to become equation 4. And then we draw our line. How do we change equation 1 to equation 3? We stand on equation 1. And then we look down. What number do we see? 4. So we multiply the whole of equation 1 by the 4 that we are seeing. And so 4 times 3x will give us 12x plus 4 times 4y will give us 16y. I hope you have your calculators by you so that the heavy calculations will help me get the answers. And then the last one, we have 4 multiplied by 6350. And that would be 25,400. That is equation 3. So then the next thing to do is now to come and stand on equation 2. We are changing it to 4. So we stand on equation 2 and then we look up. What number do we see? 3. So we multiply the whole of equation 2 by the 3 we are seeing. And so we have 4x times 3, you have 12x plus 3y times 3, you have 9y is equal to the right-hand side, which is 6950 multiplied by 3. And that will give you 2850. That is equation 4. Then we subtract 4 from 3. So we do 3 minus 4. So 12x minus 12x will give us 0. And then 16y minus 9y will give us 7y. Then we come to the right-hand side. So the right-hand side, we have 25,400 minus 20,850, and we'll have 4550. So then this is what we have. 7y is equal to 4550. We divide every side by 7. So y can stand alone. 7 will cancel 7. So we have y is equal to, if you do your computation very well, you have 650 for y. Now, when we want x, you pick any of the equations, either equation 1 or equation 2. So let's pick equation 1. 3x plus 4y is equal to 6350. So 3x plus 4y means 4 multiplied by 650 is equal to 6350. 3x plus 2,600 is equal to 6,350. 3x is equal to 6,350 minus 2,600. I want you to be checking with your calculator the subtractions and additions that I'm doing to make sure we are on track. So this one, 3x, will give us 3,750. So now let's conclude with the x. Finally, x will stand alone, so we divide every side by 3. So this cancels this. Therefore, x is equal to 1,250. That's the answer. Meaning that the iPhone X is costing 1,250 Ghana cedis, and then the Android phone Y is also costing 650 Ghana cedis. And we have solved this real life scenario, even though we were not with Peter and James. But the information they have given us, we've been able to write them in the form of an equation, and we have solved it to now know the price of the iPhone and the price of the Android phone, which the question was asking us to find. At the end of the day, we've been able to find it that X, which is the iPhone, is 1,250 Ghana cedis, and then the Android is 650 Ghana cedis. This is how you can use simultaneous equation to solve a real life problem. Any question about this solution? All right, so with this story problem, because our time is up, we cannot do a second example. So what I want you to do is to go through the other examples that I have. So if you look at this one, it's about computers and executive chairs. Okay. And a total price. Computers and executive chairs. Okay. Total price. Same total price. Means that same 1,700. Find the cost of one computer. Find the cost of one executive chair. So you can represent this computer by X, represent the executive chair by Y, and then you do your simultaneous equation. Another example, 5 loaves of bread, 3 sachets of margarine, costing 8 cedis. 2 loaves of bread, 6 sachets of margarine, costing 5 cedis, 60 pesos. So find the price of X, which is bread, margarine, which is Y. Simultaneous. Then the last one, a landscaping company placed 2 orders with the nursery. The first order is 13 bushes and then 4 trees, costing 487. So this was first order. Second order, 6 bushes, 2 trees, costing 232. What is the cost of one bush. You let X represent bush. One tree, you let Y represent tree. Once you get your X and Y, you have solved the problem. And that is the end of our lectures today. And because our time is up, I have to stop at this point. And the next time we'll meet face to face, God willing, next week for our last topic or our last class. On that note, I want to thank you for your usual participation. I wish you the best of the day and a good weekend. The class is officially ended for today.